Hello everyone, very good morning and very sorry for the late for some technical issue. Uh, very good morning Abhi, very good morning Hamanto, and welcome to MX Live. And in this series, I will be dealing with fluid mechanics and especially the previous year's question of 20 years of SSCJE of the subject fluid mechanics. We have already complete 40 questions of the first chapter and आज हम फर्स्ट चैप्टर का बाकी कुछ क्वेश्चन है वो करेंगे. ठीक, आई होप माई ऑडियो एंड वीडियो इज क्लियर, राइट? सो आई होप इट विल बी क्लियर, इट शुड बी क्लियर. थोड़ा नेट इशू था, इसके लिए थोड़ा लेट हुआ, माफ़ी उसके लिए. एंड सो लेट अस स्टार्ट and let us not waste time. Already we are late today. Okay, so already we have completed 40 questions of the first chapter, which is fluid properties, right? So we have discussed about dynamic viscosity, kinematic viscosity. We have discussed about the units of those, and we have discussed about the density with temperature, pressure, everything. And in this session we will deal again with 20 more questions of that the first chapter, and then from tomorrow we will be going to the second chapter. So first chapter is going to be end today in this session, right? So the name of the chapter is fluid properties. So let us come to the first question. The first question is saying that the compressibility of the fluid is given as 5 × 10 to the power minus 11 per Pascal, right? So what is the bulk modulus in gigapascal? तो हम लोग को कॉम्प्रेसिबिलिटी दिया हुआ है, हम लोग को बल्क मॉड्यूलस निकालना है. ठीक है, तो बिफोर गोइंग टू द सॉल्यूशन ऑफ द क्वेश्चन, एंड आई वुड like to describe what is bulk modulus and what is compressibility and what is the relation between those, right? So let us start with the bulk modulus. This is denoted as K. Bulk modulus is denoted as K, right? So let us assume any particle or any object which is having a volume of V. So let us suppose that the volume of this is V, okay, and the pressure which is exerted upon this, we denote this as the pressure is denoted as P here. Okay, now after some time in the second object, this is not the second object, this is the same object, but after some time, after applying some pressure, when we increase the pressure here, so we get this volume. So let us assume that the pressure for after time dt, the pressure is here P plus dP. What is dP? dP is the change in pressure. So obviously the pressure is increasing, and with the increase of pressure, the volume will be decreased. So let us suppose that the volume is right now V minus dV. Obviously the volume is decreasing. So if I want to calculate the change in pressure, what will be this? This will be P plus dP minus P. This is the change in pressure and it will be dP, obviously. And if we want to calculate the change in volume, so what we can get? It will be V minus dV and minus V. So it will be coming out as negative dV because the volume is in decreasing form, so it will be in negative manner, right? So now what is bulk modulus? Bulk modulus is nothing but the change of pressure with respect to the rate of change of volume. तो हम बोल सकते हैं, do you know about strain? What is strain? That is change in length upon initial length. Okay, so don't it look like some thing like strain or volumetric strain, because this is dV is change in volume, and upon V, that is called as the initial volume. So it is change in volume upon initial volume. So we can say this as volumetric strain. So what is bulk modulus then? Bulk modulus is the change of pressure with respect to the volumetric strain, right? So this is bulk modulus and this is the equation for bulk modulus. Now, what is compressibility? So let us calculate the compressibility. So before going to the calculation of compressibility, let us write the definition for compressibility. What is the definition for compressibility? So it is the variation of volume or density to a given mass. इसका मतलब है mass will be constant for that compressibility. Mass will be given constant. So for a given mass with respect to pressure. So bulk modulus क्या था? Bulk modulus था change in pressure with respect to change in volume, right? लेकिन compressibility क्या है? It is the variation of volume or density. तो ये volume का change है, change in volume with respect to pressure, right? तो compressibility is mathematically reciprocal of bulk modulus. So this is generally reciprocal of bulk modulus. So that is, we can denote compressibility by beta, okay, or you can also denote as C as well. So beta will be reciprocal of bulk modulus, okay. The audio is somehow feeling like robotic. Just a second. हेलो हेलो, अभी सही है कि नहीं है? Just confirm once. Is it okay right now? Please confirm the audio. ठीक है, राइट. सो वी आर गुड टू गो हियर. तो हम लोग कहाँ था? तो ये अब तक हम देखे कि compressibility इज मैथमेटिकली रेसिप्रोकल ऑफ वर्क मॉड्यूलस, राइट. तो अभी हम देखेंगे कि इसका अगर हम मैथमेटिकल एक्सप्रेशन निकालना चाहे, तो इफ वी वांट टू कैलकुलेट द मैथमेटिकल एक्सप्रेशन फॉर compressibility, so what we can get, right? So obviously k is equals to dp upon minus dv by v. This is the equation which is there in our hand. Sir, it is okay. Now what we can write, that is, we can start with rho. What is density? Density is mass upon volume, right? Basically, let us assume a container. So basically, this is a container where, let us suppose that there is some fluid between the container. In the container, there is some amount of fluid, right? Now we are exerting pressure to the fluid from the top portion, right? If we exert the pressure P, and it is given that the mass of the fluid is constant. Mass is given, and if we give pressure to that particular fluid, the mass will be not changed. At the change we can see, we can observe the change in the volume, because with the increase of pressure the volume will decrease, not the mass. So mass is constant. So if I want to calculate the rho, that means the density of that particular fluid, what we can get, that rho is equals to mass upon volume, but the mass is constant. But in this case, the rho can be changed with the change of volume. So with the increase of pressure, the volume will be decreasing and the rho will be decreased. So in this case, we can write that m, which is mass, is constant, but rho v is not. Rho is also changing and v is also changing. So we can differentiate with rho and v. So if we want to differentiate, what we can get here? Okay, wait a second. Okay, so d rho upon dv plus, oh, wait a second. Just a second. Just a second. The pen tab is not working. Just a second. Wait, just let me refresh once. Just let me refresh once. Very sorry. Very sorry. This is working. This is with mouse. This is working, but this pen tab is not working properly. Can you repeat this? Obviously, Hemant, I will repeat, but just give me some minutes. Just my pen tab is not working properly. It is not working. Whenever I'm trying to write with the pen tab, it is not taking, but it is with the mouse. It is working, right? So just give me 1 second. Let me connect the pen tab. Very sorry, guys. Very sorry for the inconvenience. Very sorry. Okay, okay. Very sorry for the inconvenience. Actually, the pen tab was stuck. Right. So, okay, sir, take it up. Okay, Hemanta. So, okay, he has asked me to repeat the lines. So, from where you want to listen again? So, okay, let me repeat this once again. Okay. So, I was there in the bulk modulus. What is bulk modulus? Bulk modulus क्या है? If we take a body जिसका पहले वॉल्यूम था V, ठीक है, and the pressure exerted was upon the body was P. After some time, we increase the pressure, and we increase the pressure up to P plus dP. So we have increased the pressure by the amount of dP, right? So obviously, okay, the last line. Obviously, so let us finish. Let us repeat once the bulk modulus 2. So with the change or with the increasement of the pressure, obviously the volume will be decreased, right? So volume, when the volume will be decreased, so we can see the changes. So particularly the bulk modulus is nothing but the change of pressure upon the change of volume. So this is minus dV by V, which is the volumetric strain as well. I can see this is minus dV by V is volumetric strain. And why we are using the negative sign over there? Because we know as the dV is in negative form, because the volume is decreasing. So to keep the value in a positive manner, we are using this negative sign. Okay. So then we come to compressibility. So compressibility is mathematically the reciprocal of bulk modulus, we have said. Now our experiment, come back to our experiment. So we have taken a container. In this container we have taken a fluid sample. Okay. Now what we are doing, we are increasing the pressure from the top of that particular fluid, and we know the mass of the fluid is constant. ठीक है, फ्लूइड का जो मास है वो कांस्टेंट है, लेकिन विद द इंक्रीज ऑफ प्रेशर the volume will be decreased, that we know. So we know the relationship, we know the definition of rho, that is density. What is density? Density is mass upon volume, but in this case the mass is constant. Okay, so this rho and this volume, if I multiply this, so this mass will be constant, so this is a constant value. Good morning, Surendra. Good morning. So we were today we are discussing about the first chapter, the fluid property, and we will discuss some questions about this chapter. And we have discussed more than 40 questions in the previous lecture. So if you have missed those, you can watch those after this lesson, right? So come to the equation. It is rho into V is equals to mass, which is constant. So if this is the constant, but those two are changing. Rho is changing because the volume is changing, and with the increase of pressure the volume is decreasing. So the rho and volume both are changing. So if we differentiate those, so we find here rho dV plus V dρ is equals to, it will be 0, as the mass is constant, it will be 0. So let us calculate with, if I want to calculate in this form, we have to calculate minus dV by d. So we have dV here. Let us send this to right hand side. So it will be minus dV into d rho. Okay. Now here it is rho dV is equals to minus V dρ. So if I take this again in the left hand side, it will be coming as minus V, and if I send this rho to the right hand side, it will be coming as dρ upon rho. So what we are getting, minus dV by V is equals to dρ upon rho. We are getting this equation, minus dV by V is equals to dρ by rho. Now we can use the compressibility is dP by minus dV by V. Now we can use dP upon d rho by rho. Just we are replacing this value with that value, right? We are replacing the value of dV by V with d rho by rho. We are getting this as compressibility. Now, bulk modulus. So, if I want to calculate compressibility, it will be reciprocal of bulk modulus, that is 1 by k. So, 1 by k, if we do, what can we get? That is, for this, let us simplify these ones. So, this is rho dp upon d rho, right? So, for the case of compressibility, which is beta, we will find that 1 by rho upon d rho by dp. So, this is basically the mathematical expression for bulk modulus, compressibility and bulk modulus too. So that is our compressibility, and obviously if the quantity d rho upon dp is 0, if this is 0, we can say that the fluid is incompressible. Okay, so basically for ideal fluid, the ideal fluid is incompressible. For ideal fluid, the change of density with respect to the change of pressure is 0. That means if you to an ideal fluid, if you give exact pressure from the top, the volume will be unchanged. You cannot change the volume, so it is an incompressible fluid, right? So now that was the theory part, and that was the relation between compressibility and bulk modulus. But we have to solve this problem, right? We have to solve this problem where the bulk modulus is given. Sorry, the compressibility is given, but the bulk modulus we have to calculate. Now let us solve the question. In the given data, the compressibility is given as 5 into 10 to the power minus 11 per Pascal. Now we need the bulk modulus. So obviously the bulk modulus is, if beta is equals to 1 by k, so k will be is equals to 1 by beta. Now we can write this as 1 by 5 into 10 to the power minus 11 Pascal will be the unit. If we solve this, we will find here 2 into 10 to the power 10 Pascal. Yes, we will find 2 into 10 to the power 10 Pascal. Now the answer is required in the form of gigapascal, right? The answer we need in gigapascal. So obviously it will be 2 into 10 to the power 1. That means 10 to the power 1 gigapascal is equals to 10 to the power 9 pascal. So it will be nothing but 20 gigapascal. So the answer will be 20 gigapascal. So obviously the C option will be correct. That was our very first questions which we have solved. Not only the question we have solved, we have discussed about the relation between bulk modulus and compressibility. I hope this concept and the question is clear to all. If this is clear, just tell me in the comment box if it is clear or not. Okay, I hope it will be clear. And now let us go to the next question. The next question is saying that the calculate the kinematic viscosity in Stoke of the fluid if the dynamic viscosity of fluid is 0.5 points and the specific gravity is given as 0.4. Okay, so we have the data of kinematic viscosity, and we need to calculate the we need to calculate the kinematic viscosity, but we have as a data we have the dynamic viscosity and we have the specific gravity. Now let us calculate the kinematic viscosity. We need to calculate, right? So what is the kinematic viscosity? It is nu is equals to dynamic viscosity upon the density. Okay, now we are having some data here. The specific gravity is given as 0.4. What is specific gravity? Specific gravity is rho of any fluid upon rho of standard fluid. Right, it is the rho of any fluid with the rho of standard fluid. But in the question, is there anything written like it is a liquid? No, it is not written like liquid. But whenever in any problem, it is, if it is not given that either the fluid is liquid or in gaseous form, so we will assume the fluid to be a liquid. Okay, so let us suppose that the rho is a liquid. So our liquid has a rho which we have to calculate, but we know the rho of standard liquid, that is water. So that is rho of our liquid 2000, that is equals to 0.4. So we get rho liquid is 400. Now the dynamic viscosity is given. What is the dynamic viscosity? It is given is in poise, which is 0.5 poise. Right, it is given in poise. So we can say the poise is gram per semisecond, right? And the kinematic viscosity, they want the kinematic viscosity in the unit of Stoke. So what is the unit they need for the kinematic viscosity in Stoke? Obviously, which is semi square per second. So we have to convert the unit here, but it is already in gram per semisecond. We need the answer in semi square per second, but the problem is in the rho. What is rho? Rho is mass upon volume, that is kg per meter square, meter cube. We have to convert this into gram per centimeter cube. Then only we can calculate the kinematic viscosity in the unit of Stoke, right? Yes, Newton per meter second, it is right, but the thing is, it is given in poise, right? So if it is given in poise, you have to convert this. So we have to convert the unit of rho, that is density. So if it is 400 kg per meter cube, we have to convert this. If I convert the kg into gram, so it will be 1000. And now if I divide this, we have to calculate the meter cube to centimeter cube. It will be 10 to the power 9. Sorry, it will be 10 to the power 6, I hope. It will be 10 to the power 6 semi cube, and this will be in gram. So after simplifying, we will find the rho of our liquid will be 0.4 again, but the unit will be gram per semi cube. Now we are good to go. We have to just imply this on that formula, which is nu is equals to mu upon rho. So what is mu? 0.5, and this is our density, and it will be coming out to be 1.25 Stoke, which is semi square per second. So this is the answer. Option C will be the right answer for the question. I hope this is clear. It was a very easy question, but the main trick was actually hidden in the unit. Okay, you can also solve this by Newton. Just you have to do what you have to do. You have to change the unit of this mu, then you can solve this in different ways, right? I have changed the unit of density, you can change the unit of dynamic viscosity, and you can calculate obviously. And again, if you get the answer in meter square per second, if you get the answer in meter square per second, then also you can convert the unit of काइनेमेटिक विस्कोसिटी. पहले आप काइनेमेटिक विस्कोसिटी निकाल लीजिए मीटर स्क्वायर पर सेकंड में, उसके बाद आप चाहे तो उसको फिर से कन्वर्ट कर सकते हैं स्ट्रोक में, वो भी हो सकता है, लेकिन मैं आई सॉल्व दिस इन दिस वे. सो देयर आर मेनी वेज टू सॉल्व एनी क्वेश्चन, राइट? सो आई होप दिस विल बी क्लियर. Okay. Now let us come to this. The question is saying that if the velocity gradient is given by theta and the dynamic viscosity of fluid is given by mu, so what is the shear stress on the wall of the boundary layer in the direction of motion, right? We know that shear stress, the shear stress is proportional to velocity gradient. We denoted, till now we have denoted the velocity gradient as du by dy. But for this problem, it is given that the velocity gradient is theta. So we have du upon dy is equals to theta. Now convert this proportionality into equality and it will be coming as mu du dy. What is mu? Mu is kinematic viscosity. So this mu is kinematic viscosity. Sorry, this mu is dynamic viscosity. I'm so sorry. This mu is dynamic viscosity. Right. But here this is already given that we have the dynamic viscosity is mu and we already derived the mu, already हमको मिल गया mu, ठीक है? तो ये है shear stress is equals to mu and this velocity gradient is given as theta. So theta. So let us check for the options. Yes, option A will be the right answer. Mu into theta will be right answer. Easy question था. Okay. So the next question, it is saying that in which of the following unit kinematic viscosity of fluid is measured. तो kinematic viscosity का यूनिट होता है मीटर स्क्वायर पर सेकेंड, ठीक है? लेकिन इसमें इस क्वेश्चन में ये ऑप्शन कहीं दिया ही नहीं है, मीटर स्क्वायर पर सेकेंड है ही नहीं, ये मीटर पर सेकेंड है, ये मीटर पर सेकेंड स्क्वायर है, ये डाइन में दिया हुआ है. लेकिन स्टोक्स, in the previous question we have discussed about Stoke, that is semi square per second. So we can already see the unit of kinematic viscosity is Stoke because this is semi square per second. Obviously you can convert this meter square per second to semi square per second, which is called as Stoke. Okay, so option D will be the right answer for the question. Let us go to the next question. It is saying that on increasing temperature, the viscosity of gas. So yesterday I have discussed that with the increase of temperature, how the viscosity of gas changes. Already we know the molecules, the distance of molecules in gas element is already very far. So when the intermolecular force is not that high, and if you apply any shear force to the plate or if you apply any shear force to the gas, it will be very easy for you to deform the gas because the resistance which actually occurred by the intermolecular force is very weak in the case of gas. So viscosity is basically produced by the collision of the molecules of any substance, maybe fluid, maybe liquid, maybe gas. But if you increase the temperature, what will happen? The collision between these molecules will be increased with the increase of temperature. So once the collision will be increased, automatically it will be generating some resistance against the flow. So the viscosity of gas increases with the increase of temperature. I have already discussed this concept yesterday. Now let us come to the next question. What is the question saying? It is saying that the surface tension for a fluid is, the surface tension of ideal fluid is, surface tension ideal fluid का zero होता है. That is a characteristics, or you may say that is a property. So surface tension for ideal fluid is zero. Okay. Now come to next question. ये बोल रहा है कि which of the following is not true about density of the gases. Density of gases के लिए कौन सा property true नहीं है? तो बोल रहा है कि ये property ये proportional to pressure है, inversely proportional to temperature, inversely proportional to volume, do not depend on temperature and volume. Okay, so this is asking about the density and the relation of density with temperature and pressure. What is density? Density is mass upon volume. We know with the increase of pressure, the volume decreases, but the mass is remains constant. So for a constant mass, if this is constant and the volume is decreasing, so automatically the rho will be increased. So we can say that with the increase in pressure, the volume decreases. That is why the rho is increased. Obviously. Now for the temperature, if we increase the temperature, automatically with the increase of temperature the volume will be increased, and if the volume increase and this mass is constant, automatically the rho, the density will be decreasing. So with the increase in temperature, volume is decreasing, and with the decrease in volume, the volume will increase and the rho will be decreased. The volume will increase and the rho will decrease. So that is how it depends upon temperature and it depends upon pressure also. So this is the right option, which is actually a wrong statement, but the option is right for the question that which is not true about density. Okay. No. Now the question is saying that which of the following expression represent the correct relationship between the compressibility and bulk modulus. I have already discussed the compressibility and bulk modulus relation. That is, compressibility is reciprocal of bulk modulus. So that is 1 by k. Now in the isothermal condition, the isothermal bulk modulus of an ideal gas is equal to. This is a question which we have to again derive, right? So isothermal condition for an ideal fluid. Isothermal means the temperature will remain constant in the system. Okay, so we know that when we increase any pressure, we exert pressure to any particular fluid, we know that the automatically with the increase of pressure, the temperature will also increase, because it is a closed area. Obviously it will be the volume will be decreasing and the temperature will try to increase. But if the increase in temperature can come outside, so we have like the increase in temperature, if we increase the temperature, there is a way, we allow the temperature to come out of the system. So what will be happening? It will be happening that the internal temperature will remain constant. So that is isothermal, right? So What is the equation for an ideal fluid, ideal gas? It is PV is equals to mRT, where V is the volume and m is the mass. So we can write this m by V RT. So P is equals to rho RT. We can derive this, right? Now what we can do, let us differentiate, let us calculate dP by d rho. And if we calculate, obviously it will be rho T, as those are constant in this situation. In isothermal case, the temperature is constant and this is already a constant. Now we have this in our hand, right? Let us calculate the if I want to calculate the bulk modulus, it is dP upon minus dV by V, but dV by V is equals to d rho upon rho. So we can write this as rho dP by d rho, and we have dP by d rho as RT. So already we can watch this K is equals to rho into RT. So rho into RT is also same as the pressure we are giving to the system. So we can write the bulk modulus for isothermal case is same as the pressure we are applying to the system. Okay, so this will be the answer, that for isothermal condition, the isothermal bulk modulus of an ideal gas is equal to the pressure which we are giving on the system. It will be same as the pressure, right? Okay. The next question is asking the Reynolds number. Okay, but the data which are given in the question is the diameter of the sphere is given. Let us write the diameter as D, capital D, which is given as 30 centimeter. The velocity is given as 4 meter per second. Now it is given on meter per second, but this is given in centimeters. So let us change this. Let us write it as 0.3 meter. So it will be 0.3 meter. Now we have the specific gravity of the liquid is given as 0.8. So the specific gravity is given as 0.8, and sorry, the dynamic viscosity is given as 0.8 and the specific gravity is given as 0.9. So it is 0.9. Now we know that, and also it is given dynamic viscosity is 0.8. ये poise में है. So all the unit is converted. We need to calculate the rho. Rho will be, rho of our liquid will be 0.9 into 1000. वाटर की डेंसिटी से अगर मल्टीप्लाई कर देते हैं तो ये आंसर में आ जाएगा 900 kg पर मीटर क्यूब. तो सारे यूनिट केजी पर मीटर में है, ये भी मीटर में है, ये भी मीटर में है, ये भी केजी पर मीटर क्यूब में है. ठीक है, तो रेनॉल्ड्स नंबर, लेट अस चेंज द कलर. So the Reynolds number is velocity with diameter upon kinematic viscosity. So we have to calculate here the kinematic viscosity, which is dynamic viscosity upon the density. We have the dynamic viscosity given there, so we have to calculate, right? The dynamic viscosity is given as 0.08. Rho is given as 900. So it will be coming out as 8.8888 into 10 to the power minus 5 meters square per second. So we have the kinematic viscosity with us. Now let us calculate Reynolds number. So what is the velocity? Velocity is 0.4 meter. It was 4 meter per second. Sorry, not 0.4. The velocity was 4 meter per second, and the diameter we have calculated that 0.3 meter, and it is calculated as 8.8888 into 10 to the power minus 5. So the Reynolds number will be coming out as 13,500. So option C will be the correct answer. That is the correct answer for the question. I hope this is clear. The unit is very important. You have to change every unit. Okay, you have to like you don't ignore the units, because the every question is actually tricking on the unit part. We have already solved the question of kinematic viscosity. We have already solved the question of bulk modulus, but every game was in unit, so unit is very important, right? Now it is a theory question. Which of the following is measured in poise? Just now we have discussed which of the following we have measured in poise. Obviously, the dynamic viscosity is measured in poise, where the kinematic viscosity is measured in Stoke. So you have to remember, this is very basic question. Now the next question is saying, on increasing the temperature of a liquid, the viscosity of the liquid is. टेम्परेचर ऑफ लिक्विड बोला है, इस टाइम ये गैस के बारे में नहीं बोल रहे. तो गैस में क्या होता है, विद द इंक्रीज ऑफ टेम्परेचर द विस्कोसिटी आल्सो इंक्रीज. बट फॉर लिक्विड with increase in temperature the viscosity is decreased. ठीक है, तो ये होगा द आंसर इज ऑप्शन ए, ये डिक्रीज हो जाता है. Which of the following represent the unit of kinematic viscosity? सेमी स्क्वायर पर सेकंड. इस रूप में दिया हुआ है. ठीक है, ये मीटर स्क्वायर पर सेकंड भी होता है, सेमी स्क्वायर पर सेकंड भी होता है. ठीक है, ये दिया हुआ है कि bulk modulus of fluid is given by 25 gigapascal. What is the compressibility? So bulk modulus is given by 25 gigapascal. K is 25 gigapascal. Okay, so what will be beta? It will be 1 by K, obviously. So, and if I change this into Pascal, so it will be Pascal. It is already given that it is 25 gigapascal. We have to convert this into Pascal, and it will be coming as 1 by 25 into 10 to the power 9, and this will be Pascal inverse, and the answer will be coming as 4 into 10 to the power minus 11 per Pascal. So this is the right answer. This will be the right answer, option A. Now the next question is saying that the unit of dynamic viscosity of a fluid is. Dynamic viscosity का यूनिट क्या होता है? तो ये पहले भी हम डिराइव कर चुके हैं, फिर भी अगर डिराइव करना चाहे तो दिस इज dynamic shear stress is proportional to velocity gradient. Shear stress is equals to dynamic viscosity into velocity gradient. तो shear stress का क्या होता है, F by A. तो F by A का यूनिट क्या होता है, दैट इज न्यूटन पर मीटर स्क्वायर. ये हमको निकालना है. दिस इज द चेंज इन वेलोसिटी, सो इट विल बी मीटर पर सेकंड, एंड दिस इज ओनली इन मीटर. So meter will be cancelled out, and we will find that Newton second per meter square will be the unit of dynamic viscosity, and this is Newton second per meter square. So option C will be the right answer, Newton second per meter square. Okay. The next question is saying that a fluid which has shear stress is proportional to the rate of shear strain. Rate of shear strain क्या होता है, what is the rate of shear strain? d theta upon dt. We call this as angular deformation, or we can call this as rate of shear strain. So this is a न्यूटनियन फ्लूइड. ओके, इट विल नॉट न्यूटन, नॉन न्यूटनियन तो नहीं है, ठीक है, आइडियल फ्लूइड भी नहीं है. तो ये दोनों चीज के साथ होता है, ठीक है. ये टाउ इज प्रोपोर्शनल टू डी थीटा अपॉन डी टी, दैट इज दोनों केस के लिए होता है. हम प्रीवियस लेक्चर्स में बात किए थे फ्लूइड के बारे में, दैट इज बिंघम प्लास्टिक, जिसको बोला जाता है, और आइडियल प्लास्टिक फ्लूइड, जिसके एग्जाम्पल हमने दिया था टूथपेस्ट के साथ. टूथपेस्ट एक ऐसा फ्लूइड है, एक ऐसा आइडियल प्लास्टिक फ्लूइड बोलते हैं इसको, बिंघम प्लास्टिक फ्लूइड बोलते हैं. इसका ये एक्चुअली न्यूटनियन फ्लूइड नहीं होता, ठीक है. ये न्यूटन्स लॉ विस्कोसिटी को ओबे नहीं करता है, लेकिन इसका लगभग कुछ प्रॉपर्टी जो है वो न्यूटनियन फ्लूइड की तरह ही एक्ट करता है. इसका मतलब है कि एक लिमिटेड अमाउंट ऑफ शियर फोर्स के बाद, ठीक है, एक लिमिटेड अमाउंट ऑफ शियर फोर्स, एक थ्रेशोल्ड होता है इसका, उसके बाद अगर वो आप क्रॉस कर जाओगे तो उसके बाद उसका जो रेट ऑफ डिफॉर्मेशन है, जो रेट ऑफ एंगुलर डिफॉर्मेशन होता है, वो शियर स्ट्रेस के साथ प्रोपोर्शनली एक्ट करता है. बट इट स्टार्ट्स विथ अ गैप, लाइक उसको एक थ्रेशोल्ड शियर फोर्स, जैसे फॉर आइडियल फ्लूइड हुआ. व्हाट इज द कंडीशन फॉर न्यूटोनियन फ्लूइड? न्यूटोनियन फ्लूइड इज समथिंग दैट इज, इफ यू apply a minimum amount of shear force to the fluid, it will be flowing continuously it will be flowing, right? But for ideal plastic fluid, with the it will resist some shear force at the very first, ठीक है. तो ये पहले जब you will start giving the shear stress, it will resist some amount of shear stress, but after the threshold you cause the shear stress, then it will start deform, but the deformation is similar to the Newtonian fluid. So this is the option which is correct, that is ideal plastic fluid. So obviously if this is the shear stress and this is the deformation, so for Newtonian fluid we can find this is the Newtonian fluid, which is linear, which acts linear with the change of the shear force. The relationship between shear force and the deformation is linear. Okay, it is proportional. And for Bingham plastic or ideal plastic fluid, you will find this as here. And this distance, this is called as B. This B is the threshold shear stress which you need to make an ideal plastic fluid to flow. उसको फ्लो करवाने के लिए जो मिनिमम थ्रेशोल्ड शियर फोर्स आपको चाहिए होगा, दैट इज कॉल्ड एज बी. तो दैट इज द डिफरेंस बिटवीन बिंघम प्लास्टिक एंड न्यूटोनियन फ्लूइड. आफ्टर द थ्रेशोल्ड इट क्रॉस, इट विल एक्ट लाइक सेम, इट विल फ्लो लाइक एन न्यूटोनियन फ्लूइड. आई होप दिस इज क्लियर, ठीक है. ये काइंड ऑफ नॉन न्यूटोनियन फ्लूइड के अंदर में ही आता है ये, ठीक है. इसको बोलते हैं बिंघम प्लास्टिक फ्लूइड. So what is the SI unit of kinematic viscosity? मीटर स्क्वायर पर सेकेंड. मीटर स्क्वायर पर सेकेंड अगर सीजीएस में करोगे, सीजीएस में आएगा सेंटीमीटर, तो उसमें ये निकल कर आता है 10 सेंटीमीटर स्क्वायर पर सेकेंड, दैट विल बी 10 स्टोक, ठीक है. सेम क्वेश्चन अगेन, which is the unit which of the following units is kinematic viscosity of fluid expressed as meter square per second? Same question has been repeated twice. It is an important question. That means it has come in the questions or in the exams various time. That is how it is repeating, right? एक ही स्लाइड में अगर बार बार एक क्वेश्चन आ रहा है, इसका मतलब है ये बहुत इंपॉर्टेंट क्वेश्चन है. ये आया हुआ है वेरियस स्टेट पीएससी जेई में आया हुआ होगा, या फिर एसएससी जेई में आया है ये बहुत बार, ठीक है. इसीलिए एक ही स्लाइड में बार बार ये क्वेश्चंस रिपीट हो रहा है. तो थैंक यू एवरीवन फॉर अटेंडिंग द क्लास. आज बहुत पहले तो डिले हो गया, बहुत प्रॉब्लम था, टेक्निकल इशू था, फिर भी हम स्टार्ट किए थोड़ी देर बाद. उसके बाद थोड़ा ये पेंटाइम प्रॉब्लम आ गया, तो थोड़ा बहुत प्रॉब्लम आज हुआ, थोड़ा बहुत आज रेजिस्टेंस आया, लेकिन नो प्रॉब्लम, ठीक है. विस्कोसिटी रहेगा, उसमें कोई प्रॉब्लम नहीं है. हम कोई आइडियल फील्ड तो है नहीं कि कोई रेजिस्टेंस के बिना ही सब कुछ कर लेंगे, राइट. तो प्रैक्टिकल सिचुएशन है, प्रॉब्लम आ सकता है, बट बहुत बहुत थैंक यू हेमंत, तो बहुत बहुत थैंक यू अभिज्ञान, अनिक, सुरेंद्र एंड द मास्ट गेमर. Thank you for attending the class, and thank you for like uh, if you are liking the class, you can obviously subscribe to the channel. You can like the video, and you can also share with your friends. And obviously, if you have any doubt regarding the class, if you have any feedback regarding the class, so you can obviously comment down. And so thank you everyone, and again हम मिलते हैं कल फिर से एक नया चैप्टर के साथ. ये फर्स्ट चैप्टर हम लोगों का खत्म हो गया, तो ये जो फ्लूइड प्रॉपर्टीज है इट इज कंप्लीटेड. ठीक है, हमने लगभग 60 to 65 क्वेश्चन हमने किया. फ्लूइड प्रॉपर्टीज है, उसमें कुछ क्वेश्चंस रिपीटेड था. ठीक है, तो वो इम्पोर्टेंट भी था एज वेल. बहुत सारे क्वेश्चंस में जिनमें मुझे लगा कि आपको थ्योरी थोड़ा बहुत बताना चाहिए, मैंने बता दिया, वो थोड़ा डिराइव करके दिखा दिया. जो खुद थ्योरी पार्ट से क्वेश्चन आता है उसको भी थोड़ा बहुत मैंने डिस्कस कर दिया आप लोगों के साथ. ठीक है, अभी जो क्वेश्चंस जस्ट डायरेक्ट, जैसे लास्ट क्वेश्चन था डायरेक्ट क्वेश्चन यूनिट से आया है, वो तो डिस्कस करने वाला कुछ है नहीं चीज. फिर भी मैंने पिछले कुछ शायद फर्स्ट या सेकंड लेक्चर में मैंने वो काइनेमेटिक विस्कोसिटी, डायनामिक विस्कोसिटी सभी का यूनिट को डिराइव करके दिखाया है कि कैसे यूनिट आता है, हाउ द यूनिट इज deriving, maybe in SI, maybe in CGS, right? So I hope you are liking the session, and we'll come with the next chapter, hydrostatic force, in the next session. And this series will be continuing with the previous year's question for SSCJE in the subject of fluid mechanics, obviously. And once we complete this series, we will again start with another series, another PYQ. And थैंक यू एवरीवन. अभी खत्म करते हैं क्लास को. थैंक यू जुड़े रहने के लिए, थैंक यू. एंड ऑब्वियसली मिलते हैं